Hi everybody, so in this lesson we're going to use substitution to solve for x and y. And first we're going to talk about simultaneous equations. Simultaneous equations are essentially two equations that are being considered together. And when we're solving for equations, remember that what we're trying to do is we're trying to find the x and y value that make both equations in the set true. So what we're going to do to start out, when we use the substitution method, is that we're going to try to solve for one of the variables if that hasn't already been done for us. So if we look at this first set, you notice that we've got 2x minus y equals 1 and x equals negative 3y plus 11. Now what's convenient about this set is that we actually do have one equation that has been solved for a variable, and that's the bottom one. This one here. So what we're going to do is that we're going to take this value of x, which is saying that x equals negative 3y plus 11, and we're going to substitute that into the top equation. And so what that looks like is that we're going to take 2 times negative 3y plus 11 minus y equals 1. So you notice that all I've done is that I've taken this expression below that was set equal to x, and I've substituted it into the equation above. And now it's a matter of just solving for y with this equation. So I'm going to use the distributive property here. So what I've got from this process is I've got that y equals 3. So now I know that y is going to equal 3. That's going to be one of our solutions. So we do need an x and a y pair to solve. So what I can do now is that I can choose one of the equations to plug this value 3 in for y. So I'm going to do that with the top equation, and I'm going to do that down here. So I'm just going to take 2x minus 3 equals 1. And then I'm going to solve for x. And voila, so I have x equals 2 and x equals 3. So my solution to this, I'll write up here, x equals 2, y equals 3. Sorry, I think I said before both x's. X equals 2, y equals 3. And if we wanted to double check that, we could plug it in. All right, let's do this one on the bottom. So what's different about this set, actually kind of similar, is that we still have, in the bottom part, we have one of the equations already solved for y. And so what we're going to do is that we're going to recognize, okay, if y equals negative 3x plus 8, then what I can do is substitute that negative 3 plus 8 in for y in the equation above. So that's what I'm going to do. There we go. Draw a line here. Get this out of the way. I'm going to go ahead and solve this. Okay, so we got that x equals 4 for this set. And then what I'm going to do is I'm going to take that x equals 4, oops, and I'm going to plug it into whichever equation I think is easiest. And actually, I'm kind of looking at the y equals negative 3x plus 8, and I'm thinking that might be a little bit easier to solve for y. So again, I'm just going to take that x value that I found, plug it in for y there. And I get y equals negative 4. So my solution to this set of simultaneous equations is x equals 4, whoops, and y equals negative 4 right here. So take a look at the set for this one and give it a shot. Okay, everybody, so this is problem set